instead of dealing with the standard normal, we're actually going to change the mean and the standard deviation. We call this for measurements or for continuous data in general. So we're going to skip the whole z-score process and realize what I'm really doing is I am really finding a z-score, but I'm going to let the calculator find the z-score for me this time. So one way to do it is to find z-scores and use the z-scores to find area. And that process works every time. Another process that works every time and is more efficient is just changing the mean and standard deviation within your calculator and letting your calculator do all the work for you. So here's an example of what I mean by that. Look at example 2. It says a customer calling a call center spends an average of 45 minutes on hold during the peak season, with the standard deviation of 8 minutes. Suppose these times are normally distributed. Find the probability the customer will be on hold for each interval of times. The key thing here is that they tell us that things are normally distributed. And when we see things that are normally distributed like this, our first thought should be, let's draw a normal curve. So I'm going to draw a normal curve. And on this normal curve, I'm going to label the mean of it. And they tell me that the mean is 45 minutes. So I know that my mean sits at 45 minutes and it had a standard deviation of 8 minutes. So I know the mean is 45. You always set the mean of the curve first. Now, we can notate this, and you're supposed to notate this like this. Let X represent the amount of time a customer spends on hold. Then X follows an approximately normal distribution or a normal distribution with a mean of 45 and a standard deviation of 8. That's how we notate a normal distribution. This gives us both the parameters. And the parameters here are the value of 8 of, the mean is 8 and standard deviation is 45. So the first question says, what's the probability that it is more than 54 minutes? What we're going to do again is, we're going to draw this curve again now. And again on the curve, we're going to put the mean. And this time the mean is at 45. And the value that I'm interested in though is this value right here at 54 minutes. And so on my curve, I need to locate 54. Is it on the right or the left-hand side of the mean? Well, 54 is bigger than 45, so it's somewhere on the right-hand side of the mean. And the second part is I need to figure out how I'm going to shade the curve. Because they tell me that it's more than, because they say more than, I'm going to shade this curve where the numbers are more than 54, and that would be to the right. So when I do that, I see what kind of curve this is. It's an upper curve. And I know that my lower bound here, again, I'm going to use normal CDF. I know my lower bound. The starting point is this actual value right here. In the last video, we did a z-score right here. But now we see that this actual value is 54. So I'm going to put a 54 here. I'm going to give it a upper value or an upper bound. And it goes on like this forever in this direction. So that means that that upper bound is going to be those 9s. And again, we need at least 3 9s here because we have 2 in the mean. We always do 1 more 9 than the number in the mean. And here's what's different about the problem now also. Instead of calling the mean 0, standard deviation 1, because we were in a standard normal in the last video, we're going to actually give the mean of the problem, which is 45. And it has a standard deviation of whatever's in the problem, which is 8. So now when we go to calculate this, we'll go back to our calculators. And we'll go second, vars, normal CDF, number 2. Our lower bound is 54. Our upper bound, 999. Our mean is 45. And our standard deviation is 8. Paste that in. And we get this right here for our probability. So that means that this area right here is 0.130. It's about 13% of the area to that side. That makes sense because it should be lower than 50% because we don't even have the mean coverage in this. Now, you can also do this with the z-score if you wanted to. Here's how you would do that. Z is equal to x minus mu over sigma. Well, our x here is this value 54. So we would have 54 minus, the mean is 45, and sigma is 8. So I'm going to calculate that over here in my calculator. So 54 minus 45 divided by 8. I get 1.1125. So the next thing I would do then is, that means that this 54 sitting right here, if we were to put that on a standard normal curve, remember standard normal has a mean of 0. We'll put 1.125 here, and we would shade it again. It's still going to shade to the right. So you're looking at the exact same curve, except you standardized it now. So here's what that curve looks like, and we standardized it. Mean of 0, z-score is 1.1125. So now all we have to do is go calculate that actual area. So remember, to calculate that area, we're going to go one second. We're going to go second bars, normal CDF number 2. The lower bound this time, we're looking at this, our lower bound is this z-score, 1.125. Our upper bound is still going to be, you see our upper bound goes on forever, so that's 999. Our mean, now we are on the standard normal. So our mean is going to be 0. And our standard deviation on the standard normal is 1. Type that in. And we get this value again, 0.13029. Now, which method was quicker? Well, it was a lot quicker to skip this whole z-score process and go straight from the problem like this. So you can do it either way. Z-scores always work, but this other method is a lot more efficient. So let's try one more. Let's look at the one that says less than 32 minutes. So I'm going to do B down here. So again, I'm going to draw my normal curve. The mean of this curve is 45. So I'm interested in 32. So 32 is somewhere on this side of 45. Less than means shade to the left. All the values less than 32 are out here. This time I can see that my lower bound is going to go on forever to negative infinity, or negative 9999. Again, I need at least 3, one more than the mean. And I'm going to do normal CDF. The lower bound, negative 999 on the left. The shading starts on the left at negative 9999. It ends at 32. The mean of the curve is 45, and the standard deviation is 8. So now to calculate this, second bars, number 2. Lower bound this time is negative 9999. Upper bound is 32. The mean is 45. Standard deviation is 8. Paste this in. And we get this value here. So this little bitty area out here is equal to 0.052.